Now let's continue. Now I'll talk of notation of any matrices. In general, matrix is denoted by capital M, that is equivalent to square brackets of the order m by n. That means m rows and n columns are there. So m rows. First element is given by A11, where first one is given for the first row, and being in first column it is given again 1. So A11 mean there is an element of row 1 and column 1. Similarly, row 1 and column 2 until row 1 and column n. Similarly, if I move down the column, then it is A, mth row and first column. And at last, it is the element at mth row and nth column. So this is the general notation of any matrices. Now we'll talk of properties of matrices. First we'll talk of equality of matrices. When two matrices they are said to be equal. Condition number 1. When they have same order. When they have same order, they are said to be equal in nature. Two matrices they are said to be equal whenever they have the same order. Second condition is the elements of the first matrices must perfectly coincide with the element of the second matrices. Now, for example, a matrices containing of order 2 by 2 and another matrix is again of order 2 by 2. This contains 1, 3, 2, 4 and this also contains 1, 3, 2, 4. Now here order is same and now first element perfectly coinciding with the first element of the second matrices, second element and so on, all the elements they perfectly coincide with the elements of the second matrices. Then they are said to be equal in nature. Then if I change the position of these elements, that is 1, 3, 4, 2. Now these two elements they are perfectly coinciding, but these two elements they are reversed. Now these two matrices cannot be said to be equal. So therefore, for equality of matrices, both first and the second condition must be satisfied. Now we'll talk of operations on matrices. That is how matrices they can be added, subtracted or multiplied or divided. Now for addition, suppose our matrices is A, B, C, D on addition with any another matrix E, F, G, H. Then the resulting matrix. Now for addition, the first condition that is discussed in the equality of matrices must be satisfied. That is, both matrices must have the same order for addition purpose. So for resulting matrix, that would be again of the order 2 by 2. Now for addition, add first element with the first element, that is A plus E, C plus F, B plus G and D plus H. So this would be the direct addition of any two matrices. If I talk of subtraction, that would be also having the same phenomena like addition. Now any matrix A, B, C, D on subtraction with E, F, G, H of same order, then the resulting matrix would be of same order 2 by 2 and this would be A minus E, C minus F, B minus G and D minus H. So this is the subtraction phenomena. So for both addition and subtraction, first condition of equality of matrices must be satisfied. Next is multiplication of any matrix by a scalar quantity. So any scalar constant k, if multiplied by a matrix A, B, C, D, then the resulting matrix would be directly that k would be multiplied with A. forming AK, BK, CK and DK. So this is multiplication of a matrix by a scalar quantity. We'll continue with the rest of the chapter in the next clipping.